This video is about issues you can run into when you're trying to replace the front wheel bearings on a Harley Davidson. This is a 2011 Sportster 1200 XL Custom, and it's only got 6,500 miles on it. I'm a new owner of it, and as soon as I started driving, I noticed above 60 I had a little bit of float in the front end. It just didn't seem to be stable. So I raised the front end up, and sure enough, the front wheel bearings were noisy and slightly loose. To lift the bike, I simply welded 2 1/4-inch metal straps onto my Harbor Freight aluminum jack, and that lifts the bike up no problem. Then I put a 4x4 with 2 2x4s on top of it to let the jack down on the 4x4 and 2x4s. That way it's stable while I work on it. It's got the front wheel off the ground. I purchased this wheel bearing removal set from Amazon, and it has a couple of issues. The first issue has to do with this bolt right here. If you look at the left end, that's supposed to spread the cheeks on that other bolt up there. And there's no way to hold this bolt from turning while I tighten the nut. Let me clarify on this point. They do in fact say to use a 3/8 Allen wrench to hold the expanding bolt. The problem is that all the Allen wrenches I have, 3/8 or 8mm both, only have 4-inch shanks on them. So they're not long enough to reach through the wheel. So you have to have an Allen wrench that's either longer than 6 inches or longer, or you have to have a socket head 3/8 inch Allen wrench to reach in there on extension so that you can hold this. Just remember, it takes a lot of torque to break these bearings loose when they've been in there a long time. I had a large, I'd say 14-inch long end wrench that I used to turn this nut, and it took just about all the force I could put on it. The same force needs to be applied over here on the Allen head. The centerpiece doesn't turn on the race of the bearing. Also, the kit instructions specify this large nut as a 1 1/8 inch wrench to fit it. Well, it's not true. It's a 1 16th inch wrench to fit it. So apparently they replaced the nut with this newer nut, and that's probably why the washer doesn't work. The other nut was bigger in diameter, can handle that washer. The washer they included in the kit is 7/8 of an inch hole in the center, and yet the threaded nut that uses it is 3/4 inch National Fine 16 threads per inch. As you may be able to see, I had to chew up the end of this bolt with vice grips in order to hold the bolt from turning while I tightened the nut to spread the cheeks to grip the bearing. The other problem with this bearing kit has to do with this washer they provided that goes with this nut. The hole in the washer is way too big, and the corners of the nut actually start gouging out the washer, which makes everything turn hard. So that was the problem. For removing the second front wheel bearing, I used this electrical box jam nut, which just happened to be the right diameter to fill the void in that big flat washer and make the flats of the nut right on this instead of the corners of the nut right in on the flat washer. And this made a much easier job of pulling the second wheel bearing. Both wheel bearings were damaged by rust, and this rust somehow got into the hub of the front wheel. And it's always on the inside of the bearing, inside the hub. There was no rust on the outside of the bearings. So the rust was from moisture inside the hub, and it also damaged the spacer inside the hub. So I cleaned both bearing surface mating portions of the hub, and I cleaned the spacer between the wheel bearings and put the thing all back together. So the bottom line is that moisture gets in that hub, it damages the wheel bearings. It's only 6,500 miles on it. And this bike was stored in garages the whole time. Bottom line is I can't recommend this bearing puller set. This picture shows it all. You have to have vice grips on the end of the bolt to tighten the center bolt. These vice grips also hold the middle bolt here from turning, because at the other end of it's connected to a bearing race. There's nothing to stop it from turning. The hub on the outside has nothing to do with stopping that center bolt from turning either. So that's the bottom line. As you can see in this picture, when you tighten that center bolt, it expands this hub which grips the race of the bearing and leaves a slot right there. So in the heat of getting the job done, while this thing was installed in the wheel, I simply drove a screwdriver into that slot as shown here in this picture. And that gave me a leverage point to hold the center bolt from turning while I turned the large nut to pull the bearing out of its housing. As I said earlier, this large flat washer should have been a 3/4 inch washer instead of a 7/8 inch washer. It does not work with this nut that they provided. So you can still use this kit as long as you provide your own 3/8 inch Allen socket and extension to reach in through the wheel. And also if you go down to the local hardware and buy yourself a 3/4 inch flat washer. I would be glad to hear any ideas about how the moisture gets into the center of this hub. I don't know if these spokes pass through to the outer rim so that moisture in the air and the tire can get into the center hub. I just don't know. Any suggestions would be appreciated. Actually, I just realized, thinking about my Navy career, how this moisture gets inside the wheel. We had a problem with antenna couplers on Navy ships. It's a sealed unit with air inside. What would happen during the day, the unit would get really hot and the air would expand. And it'll find a way to get past a seal or a gasket or anything. Then at nighttime, the thing cools down and that volume inside the sealed container gets smaller, therefore it tries to draw outside air in, and the outside air brings moisture with it. Then the cycle repeats day after day after day, and eventually you have a lot of moisture inside the sealed container. I think that's what's happening here. It's being drawn through the wheel bearings. Yeah, they have seals, but the seals are just to keep dirt out. The seals are not air pressure proof, so I'm sure that that's what's happening. The moisture is coming around the seals. As each time the wheel cools down, it draws outside air in. I think that's where it's coming from. The final Navy solution was to fill the void with nitrogen and to make the pressure higher than the highest pressure you ever expect to find from the outside ambient air pressure. And that seemed to solve the problem. Just having the inert gas not enough. It's got to have pressure so that the inside of the container never sees a pressure that's less than the outside air temperature. I smeared some high temperature axle grease all over the spacer in the middle so it wouldn't rust so bad again if it did get moisture. And I also put a film of axle grease on the inside of the bearings before I inserted them. So it might help keep moisture from getting past the bearing seals. Here's the sound of a good wheel bearing versus a bad wheel bearing. The good wheel bearing is the last example. One last comment has to do with removing the front wheel from the bike. A lot of people demonstrate removing the calipers and removing the fenders. I don't have to do any of that. The Sportster, even though it had a fat tire on the front, if you tilted, as you dropped the tire down a little bit and then tilted it, you could get the tire to pass the fender bolts, and you'd also get the tire brake pads to separate from the brake disc. So you didn't have to pull off the calipers, didn't have to remove the front fenders. At least I didn't.